Okay, so we're still talking about measurement. We just finished up talking about discrete or continuous variables. What researchers tend to think about a little bit more often than that is this approach. It's called the scales of measurement, sometimes called the levels of measurement. Same thing either way, levels or scales of measurement. So it's taking the same idea we've talked about, but breaking it down in a little bit finer detail. So we're going to build basically a chart here. You can see a table on the board. So it's a little bit tough because my board is smaller than a real classroom. But so this first column, level. Second column, and I had to abbreviate here. Second column is headed as different categories with a question mark. Different categories. Third column is labeled as ranked, again with a question mark. Fourth column, known distance with a question mark. And last column, true zero with a question mark. We're going to use these four basically questions to determine what the different levels are. And so we can see four of them here: nominal, ordinal, interval, and ratio. And so each of these four levels is defined by what happens over here on the board, on the chart. Nominal is the lowest level. It's the crudest level. And as we move our way down the board here, ratio is the highest level of measurement, which typically means that it tends to be the most precise. So just like we discussed with discrete and continuous, sometimes a researcher can choose, do I want to measure it this way or that way? And sometimes it's sort of preset. Sometimes a researcher can choose, do I want to measure it at the ordinal level or the interval level? The general rule of thumb is to go to the highest level you can when you're taking your measurements. You can always simplify it later. But if your original data is too simple, you can't find the complexity in it later. So you can always simplify if you need to. So let's go through these categories. The first one, nominal. If we think about that, each of these words is going to give us a clue. Nominal, names. So nominal data is basically data in the form of words, names. So the first column here asks, if you measure something at the nominal level, can you get different response categories? In other words, when you measure it, can you get different results? Is it a variable? Is it able to vary? Yes. It has to be yes. It's going to be yes on all of these, or it's not a variable and therefore isn't part of this chapter. So if we're measuring something at the nominal level, the answer is yes. I can get different answers from different people, different response categories. The next section asked, are these different response options, are they ranked? What we mean by ranked is, mathematically speaking, are some answers higher value or lower value? Are some answers worth more or less? And again, in a mathematical sense, not in a social sense. And with nominal level data, the answer to that is no. And as soon as moving across we hit a no, the rest of the chart defaults to no. So we deal with these last two columns later. So nominal level measurement means that we are measuring the measurements that we're getting, the results we're getting are the form of unranked names, words with no mathematical values. So examples I've been using earlier across the videos for this chapter, what's your favorite color? Well, you say red, that person says blue, that person says pink, that person says red again over there. Well, that's nominal level data. I'm getting different answers. But does one person have more favorite color or less favorite color? No, just a different favorite color. There's no more or less. What's your major? You're a psych major, you're a soc major, you're a nursing major, you're an anthropology major, you are a ethnobotanist major, whatever that is. Great. Are those different answers? Yes. Do they have different mathematical values? One major isn't mathematically higher or lower than another. There's no sense of more or less with them. It's just different. What kind of car do you drive? What city were you born in? What's your favorite game? All those sorts of things. Those are all very much nominal. Literally your name. What's your name? Or what's your gender? Or all that stuff. Just names. So if we move down, going to a higher level, we get to the ordinal level. Ordinal, order. So again, that's giving us a clue here. So if I'm measuring a variable at the ordinal level, Can I get different response categories? Again, it has to be yes, or it's not a variable. Are those different response categories, are those different measurement options ranked? And now they are. Now we know that some answers mathematically are more or less than others. So that brings us to the first time now to the third column, known distance. We know some answers are worth more or less mathematically. Do we know exactly how much more or less? Do we know the distance between them? And the answer here is no, we do not. Ordinal. One of the most common ordinal scales we see in the social sciences is what's called a Likert scale, or sometimes a Likert type scale. I am so far enjoying Paul's lectures in statistics. Strongly disagree, disagree, neutral, agree, strongly agree. That would be measuring at the ordinal level. We know someone who disagrees likes it less than someone who's neutral, but you don't know exactly how much less they like it or more they like it. Ordering a small pizza, medium pizza, or large pizza. Well, we know the large pizza better have more pizza in the box than the small or the medium, but exactly how much more pizza? We don't really know. Small, medium, and large cup of coffee. You get a medium, I get a small. Well, we know who has more coffee. It's ranked, but based on this information alone, you don't know exactly how much more or less. You just know a medium has more than small. So that would be examples at the ordinal level. Earlier, my example, cold, warm, hot. That's ordinal. If someone says it's cold and someone else says it's warm, we know someone thinks it's warmer or colder, but exactly how much? Run a race. I came in first place. They came in second place. You came in third place. We know who was faster. We know who was slower, but I could have beat you by a minute. I could have beat you by a year. We don't know how much faster or slower. Freshman, sophomore, junior, senior. That's ordinal. We know who has more education, more credits racked up, if you will, but we don't know exactly how much more the junior has than the sophomore. Could be 3 credits more. Could be 30 credits more. We really don't know. So moving to the next level, interval. An interval is a space. So again, it's giving us a little bit of a clue here. So if we're measuring a variable at the interval level, can we get different answers? Again, it has to be a variable, so yes. Are those answers ranked? Do they have mathematical more or less? The answer is yes. Now, do we know exactly how much more or yes? More or less? The answer is yes. So we end up with the last no down there for this idea of a true zero. For most students, it's probably the weirdest concept of all of Chapter 1, let alone of just this topic. So with interval, we get different answers. We know how far apart those answers are. We know more or less, and then we know exactly how far apart. So the example I used earlier was measuring temperature with degrees Fahrenheit. If it's 72 degrees here and it's 75 degrees somewhere else, are those different numbers, different words? Yep, 72 and 75 are different answers. Do we know which one's more and which one's less? Yep, 75 is more. Do we know exactly how much more? Yep, it's exactly 3 degrees more. We know exactly how much more. But if we are measuring at the interval level, we may measure something and get a result of 0, like 0 degrees Fahrenheit. In the case of 0 degrees Fahrenheit, that 0 is not a true 0. In other words, it doesn't literally mean nothing exists. So if you go someplace and find it 0 degrees Fahrenheit, it doesn't mean there is no temperature there. It means that it's really, really cold there. 0 is sort of an arbitrary mark on a scale. Fahrenheit took water and ice and salt and mixed it up and put it in a tube with mercury and went, yep, that's 0. So on the interval scale, that means you can get numbers that go below 0. You could go somewhere and measure and see that it is negative 10 degrees Fahrenheit or negative 50 degrees Fahrenheit. If you can get negatives, if you can get scores below 0, it means that that 0 is not literally nothing, because you can't have less than literally nothing. So that's the interval. So ratio is going to be yes all the way across. Interval and ratio are very similar. The only real difference is this true 0 business. So if we're measuring something and get a score of 0, and it truly, literally means nothing happened, nothing was observed, there's no there, then we would be at the ratio level. So the ratio, if you get a 0, it really means nothing happened. If I asked you, are you a sophomore, or a freshman, sophomore, junior, senior, we already know that's ordinal. If I asked you, how many credits do you have? It's going to either be interval or ratio. So let's think about it. One person has 30 credits, another person has 36 credits. Are those different categories? Yep, different answers, 30 and 36. Are they ranked? Do we know if someone has more or less? Yep, we know that 36 is more than 30. Do we know exactly how much more? Yep, 6 credits a difference between 36 and 30. The question now is, if you get a 0, if I say, hey, how many credits do you have? And you say, I have 0 credits. Does that literally mean you have no credits? Yeah. Could someone say they have, without being, insane or drunk or whatnot, say and be correct and say they've got negative credits? I have negative 15 credits. The lowest amount of credits you can have is no credits. So the real key between interval and ratio is with interval you can get negative numbers, with ratio you cannot. You can't get less than 0. Money, if I say how much money do you have, that's ratio. Now sometimes students say, oh, my bank tells me I've got negative money. No, if you've got a negative balance at the bank, that's a result of comparing 2 different variables, what you have and what you owe. And you subtract them and you can get a negative value. But we're talking about measuring a variable. So if I'm just measuring how much money do you have, you can't have any less money than none. Negative money, you can't reach in your pocket and show me a negative $5 bill. It doesn't exist. The least amount of money you can have is none. So money would be at the ratio level. How many credits do you have is at the ratio level. Mostly the way we measure things like time and distance, seconds would be the ratio. If I measure something and it's 0 seconds, it means literally nothing happened. And, which can be weird to think about, but think about it this way. If I'm going to time something, could my stopwatch ever give me a negative number? Not unless it's broken. If I'm going to measure something in inches, it can't be any smaller than no inches. It means it's not there. There's no negative distance in our world. So things like pounds and kilos, things like seconds and minutes and years, all of those things tend to be at the ratio level, where you can't get a raw score of a 0. So these are our 4 scales or 4 levels of measurement. And again, it's important because the level you choose, do I want to measure your education at the ordinal level, freshman, sophomore, junior, senior, or do I want to measure it at the ratio level? The choice you make as a researcher impacts what statistical analysis you can do later. Make sure you practice with these. Make sure you're able to tell the difference. If I say Tom was a researcher and measured this that way, what level is he at? You should be able to tell the difference in that. Okay, so we're going to move on with some more Chapter 1 video coming up.